Our second exploration in section 6.4 on logarithmic functions has us graphing both an exponential function and its inverse on the same graph to see what that looks like. Okay, so we're asked to graph f of x equals 2 to the x, and we've seen this plenty of times. We know that there are 3 points on there we can graph easily, and that's -1, 1 over a, 0, 1, and 1a, right? Those 3 points. -1, 1/2, 0, 1, 1, 2 for this one because a is 2. So here is our, from 6.3, here is our exponential. F of x equals 2 to the x, or y equals 2 to the x. Now, we're supposed to also graph the inverse on this graph. So, to graph the inverse, what are we going to do? What did we say we do to find the inverse? Switch x and y. So we have y equals 2 to the x. Sorry, we know what a is. 2 to the x. So in the switch, we have x equals 2 to the y. All right, well, let's figure out what points would be on there. We'll make a table. Okay, would it be easier to choose y's and get x's, or choose x's and get y's? I think we'll choose y's, right? So let's choose -1. And what do we get for x? 1/2. Choose 0, we get 1. Choose 1, we get 2. So in other words, we've just switched these, right? So the point that was -1, 1/2 is now 1/2 -1. So we could have just switched our x and y, but I wanted to show you how that works algebraically as well as graphically. So we literally just switched places with our x's and y's, but it also works with this. Okay, so let's plot these points. We have x is 1/2, y is -1, x is 1, y is 0, x is 1, we have x is 1/2, -1. Then we have 0, 1, which is x is 0, y is 1. What did I do here? I wrote those backwards, sorry. I think I was flipping them while I was talking, but these are our points. 1, 0, and 2, 1. Sometimes it's hard to talk and do this. Okay. I knew where I was trying to get to. 1, 0, and 2, 1. There we go. Okay, so now come along here and do this. And this is our f -1 of x. Okay, this is our, which is what we have, 2 to the y, right? Our log function. Okay, we'll just label it this way. So here's our function, here's our inverse of the function. And by switching x and y, look what's happened. We've actually reflected, if you draw this line that goes at a 45-degree angle through the first and third quadrant, we see that each point has reflected over that line, right? It's actually a reflection over the line that says y equals x. So when x is 1, y is 1, x is -3, y is -3, y equals x, we have flipped over that line. So let's summarize here. For our domain of the exponential function, it's all real numbers. Our range of the exponential function is 0 to infinity. Is there symmetry for this function? We've said no previously. Are there any x-intercepts? None. Are there any y-intercepts? Yes, the point x is 0, y is 1. Is this increasing or decreasing? We said it's increasing. Does it have a horizontal asymptote? Yes. Y equals 0, the x-axis. Does it have a vertical asymptote? None. Okay, I'll put none here. How about that? Okay, let's do the same now for our function here. I guess we can write our inverse function, domain. Well, now the domain, we never go below 0 for x. So 0 to positive infinity, 0 to positive infinity. What about the range? Well, low to high, it's all real numbers. Notice domain and range have switched. We switched x and y, and the domain and range switched. Does this have symmetry? None. Does it have an x-intercept? Yes, it does. The point 1, 0. Do we have a y-intercept for the inverse function? None. Is it increasing or decreasing? As x gets bigger, what's happening to y? Is y increasing or decreasing? It's increasing. Do we have a horizontal asymptote? No. Do we have a vertical asymptote? Yes, we do. It's the y-axis. What's the equation of the y-axis? X equals 0. So we can see the result of putting the two together, a function and its inverse, and the way we get those by switching x and y, and what that does graphically and to our characteristics of our graph.